what I want to do is to go over questions of alkanes with you. There are 3 types of questions you'll get, actually 4 types. There's going to be combustion questions, free radical substitution questions, questions on pollution, and then cracking. I'll share the cracking with you today. You should watch that. First, I'll do combustion questions, and along with that, combustion and pollution questions. Then I'll start with free radical questions. And then we'll do cracking questions. First, a few combustion questions to get everybody on the same page. So the first question I want to discuss with you guys, the ones not given in the homework, because I'm assuming the homework ones are the ones that are done, is question number 6. These are questions that I was trying to give you to homework yesterday, but I didn't because I wanted to go over them with you in class to make sure we don't make a mistake. The first thing I want to talk about when I look at this question, which happens to be on limonene, which is a compound drawn here, they're asking the mole ratio of carbon dioxide to water produced when this is completely burned. So first you have to understand that you have to burn this fellow. So when you burn this fellow, then you have to be able to solve it. To burning this you understand that you need a combustion equation. To have a combustion equation, your best bet is to use molecular formulae. Combustion and cracking are the 2 equations where I insist you use molecular formulae. तो इसका आपको पहले molecular formula निकालना पड़ेगा. So let's go over that. How many carbons are there in this molecular formula? 1 and then 6 in the ring, that's 7, 8, 9, 10. So this guy has 10 high carbons and hydrogens कितने हैं? 3, 2, 2, 1, 2, 1, 3, 2. And obviously these 2 don't have a hydrogen. You can count them. So this is H16. So you have C10H16. And that's really the question here. So you got C10 and H16. Where do I write this? Okay, so let's find some space here. C10H16 is going to burn in oxygen now because the question isn't about oxygen but carbon dioxide and water. I don't care how much oxygen is being used up. I don't really bother about balancing that. I want to care about how much carbon dioxide this makes. So if it's 10 C's, it'll make 10 CO2. And if it's 16 H's, it'll make 8 H2O. So the ratio of CO2 to H2O is 10:8, which also is 5:4. So therefore the answer is bravo. B. All right? So far okay? Let's scroll down. Do I want to look at this? Let's look at question number 9. That says, many reactions take place in the engine and the catalytic converter of a car. Which pair of substances is produced both by the reactions in the car engine and also in the catalytic converter? Understand that what that means is there's some things the catalytic converter does not able to change. And also understand car engine में क्या क्या बनता है? Car engine में combustion product बनते हैं, and sometimes pollutants like carbon monoxide, which is in complete combustion, and also oxides of nitrogen. But the whole catalytic converter is supposed to convert the carbon monoxide and the nitrogen monoxide to carbon dioxide and nitrogen. So which ones will not be found in the catalytic converter? First of all, if I go through all of this, catalytic converter में कौन से नहीं बचेंगे? Unburned hydrocarbon नहीं बचेगा, carbon monoxide नहीं बचेगा. So these are not. So what is the only thing that is going to be left? B. Now you might wonder, where does carbon dioxide and water form in the catalytic converter? Unburned hydrocarbons in the car engine, if they're not burnt there, will go to the catalytic converter and then get burnt there. So they will make carbon dioxide and water. So the answer here is C. So, and through the questions, I'm just revising theory. For example, I didn't do pollution theory with you, but this is the part where oxides of nitrogen can become nitrogen itself. There are other reactions in the car engine, which is carbon monoxide can be directly oxidized to carbon dioxide. There are reactions where unburnt hydrocarbons of any form will become carbon dioxides and water. Obviously the same equation that we've seen before. And then, in addition to this, why is the nitrogen oxide of nitrogen harmful? We know that carbon monoxide is harmful because that guy is poisonous. It's toxic for human beings directly. But why is this fellow poisonous? It's poisonous because indirectly it causes acid rain. And the reason why it causes acid rain is because it is able to oxidize the sulfur dioxide to sulfur trioxide. That's the main purpose. Achha, this is important in A2. Aage jaake bhi isliye equation is good. That sulfur dioxide can be catalyzed to sulfur trioxide either using vanadium 5 oxide that you studied in O levels. That was the catalytic process. In the air, the dioxide of nitrogen dioxide, provides the extra oxygen to convert it into sulfur trioxide. But isme, what happens is you need to realize that the nitrogen oxide in the air gets easily oxidized to nitrogen dioxide, which then is useful to convert sulfur dioxide to sulfur trioxide. Now, why is this reaction more harmful? You need to know this, that both sulfur dioxide and sulfur trioxide are acidic oxides. So theoretically, both of them should make acid rain. But this produces a much stronger acid. This produces a weaker acid, and this produces a much stronger acid, which is why this reaction becomes even more lethal. Because sulfur dioxide are not as bad for us as sulfur trioxide is. Because sulfur trioxide makes H2SO4, which then forms acid rain, or the main component of acid rain. And why is acid rain bad? It can kill plant life, it can raise the pH of soils, plant life in those soils, in rivers, kill aquatic life, destroy buildings, a lot of other stuff. Even bad for skin if there's acid on your skin. But major reasons are buildings, plant life, aquatic life. All three things die because of this. All right? Fine? Now, this question that I'm showing you next actually should be solved when you have done other chapters, because the 4 reactions here are only going to make sense after you've done the chapter. So, for now, you know that alkanes will undergo free radical substitution. But I will also highlight ye baki kahan milenge aapko. Electrophilic addition will be found in the chapter for aldehydes and ketones. So, if you're revising, we'll do them then. Electrophilic substitution is an A2 ka reaction. And nucleophilic addition, what am I saying? Electrophilic addition, sorry, my bad, is alkenes. I'm sorry, I read the question wrong. This is alkenes, while nucleophilic addition is aldehydes and ketones. Sorry, I read this as nucleophilic, it's electrophilic. Electrophilic addition is the next chapter. We'll start this tomorrow, by the way, alkenes. And electrophilic substitution is A2, and nucleophilic addition is aldehydes, ketones. Ek aur reaction bhi hai. You'll realize that you'll see the words addition and substitution, and electrophilic and nucleophilic. Ek nucleophilic, chotha wo bhi hai, panchwa wo bhi hai. Nucleophilic substitution. This is just additional data. This is not required. I'm just sharing this with you. This reaction will happen in halogenoalkanes. Look, my purpose with alkenes is to make you guys as much comfortable with organic chemistry as possible. That's the goal right here. So I'm just introducing you to some of the terms that aage jaake will hopefully become easier. Okay? Can I change this? Yeah? So let's look at section B now. A couple of questions here before we wrap up this particular worksheet. So in section B here, you've got to look at obviously the tables of A1, 2, 3, 1, 2, 2, 3, and 1. And here the question is about a car has a catalytic converter. On analysis, is exhaust gases shown to contain small quantities of nitrogen oxides? What modification will lower this concentration? Now, we don't want this. We want this to go away. And remember, the purpose of the catalytic converter is to convert nitrogen oxides to nitrogen. How can I make the catalyst more effective? Because lowering the exhaust concentrations of nitrogen oxide is the same as being more effective. So how can I have the catalyst more effective? I can have greater surface area, where it will increase the effectiveness of the catalyst. Q. More surface area means the reaction is faster. So the conversion of nitrogen oxide to nitrogen is going to be faster. Okay? So 1 is correct there. Now, why is 2 not correct? Because if you increase the rate of flow of the exhaust gases, then they're going to move faster over the catalytic converter. They'll have less time with the catalytic converter. They will be less likely to convert the harmful gases to nitrogen. So 2 will do the opposite. The one way to reduce nitrogen oxide was to lower the rate of exhausts, meaning gaadi slow chalaएं, accelerate kam करें. For those of you who know about cars, you know if you accelerate faster, there's a higher chance of you producing incomplete combustion or other harmful gases, because they will not be able to convert from the catalytic converter. And the third one obviously is wrong, because if you have higher temperature in the combustion engine, there is more chance of oxides of nitrogen forming, because more nitrogen can break down. So here the answer is 1 only, therefore delta. Alrighty? Yeah? Then, done ho gaya? Okay, this one is a fun question. Question number 2. Now, this is about pollution. This is the reaction, by the way, that is responsible for ozone depletion. A chlorine free radical converts the ozone molecule, which is an allotrope of oxygen, just like carbon has multiple allotropes of diamond and graphite, and converts it into oxygen. This is good for breathing, but this is great for the UV radiation reflection, but it's also poisonous. Our job is to discuss not that, but the bonding parts of it. So if you had done the free radical video, you realize that free radicals are basically those particles that have unpaired electrons. They have unpaired electrons. Now, if they have unpaired electrons, it doesn't mean they're charged. It's just that, for example, chlorine jo hai ye, this guy is 7 electrons like this. So one of them electrons is unpaired. That's what it is. Unpaired right here. Now, on the other hand, when this happens, they are actually talking about the chlorine oxide radical, ClO. A good way to answer this would be to actually to draw the ClO in what you think is possible. Okay, what would this radical look like? You know that one of the 2 atoms will have an unpaired electron, and they're going to have a bond in between. Iske liye you should remember the number of outermost electrons chlorine and oxygen have. Chlorine is in group 17, so outermost electron is 7. Oxygen is group 16, outermost electron is 6. This would only want to share 1, but this wants to share 2. If this shares 2, this will exceed the octet. So let's try to not exceed the octet if possible first, and see if you can come up with the bonding. So what you do is, you make a dot and cross for Cl and O. So this is Cl and this is O. So let's say Cl ki mujhe kitne, I need to share electrons here. So most likely what they're sharing is 1 each. So 1 from Cl and 1 from O. So Cl has, if it's sharing 1, how many is it unshared? 6. And if I draw the 6 out, they would now have 8 complete octet. All 3 are paired, and this is the 4th shared pair. And this is a single covalent bond. Now we go to oxygen, because this chlorine seems to be satisfied. Yeah? Now we go to oxygen. Oxygen has how many electrons? 6. So 1, 2, 3, 4, 5, 6. Now what do we see? Because they're telling me it's a free radical, so one of them is going to have unpaired electrons. And obviously, you can only have unpaired by having less electrons. You can't have more than 8 and be unpaired. You'll realize that free radicals do not fulfill their octet and have less electrons. So here, oxygen ke paas, it's sharing 1, has its own 6, didn't complete the octet, but also has an unpaired electron. This is the most likely structure for ClO, given the bonding rules that you've studied. According to this now, what answers are correct? Does it have an odd number of electrons? Yes. That is going to be default. Every time you're going to have a free radical, you are going to have an odd number of electrons. Ye baat yaad rakh lein aap log, because free radicals will be unpaired electrons. Unpaired means not paired. Paired is 2. Unpaired would never form. Not be 2. Not be 2 will be 1. So odd number honge. Acha, is it a single covalent bond? Yes. But it's definitely not a dative bond. And if you were to make a dative bond, you might realize this, that then chlorine will have an influence of 9 electrons. Because 7 apne honge iske and 2 from oxygen. That's 9. And secondly, if oxygen were to have 2 of its here, it would still not have an octet complete. So you're not going to have a bond where neither of the 2 atoms have their octet complete. At least one should be. Ek to satisfy kar dena hum. Which is why this is the most likely structure of ClO, and that's why option number 3 is incorrect. So 1 and 2 are correct, the answer is bravo. Okay? Now turn to alkane worksheet number 3, question number 40, please. 43. Yeah, 43 and 44. I want to focus on first combustion and pollution quickly, and then. So now in 43, even though this was not an alkane, but the reaction is combustion, and I want to discuss combustion with you guys. So 43 and 44 are similar. I'll do the larger alcohol because that will be harder. I mean, less. This other one will be easier than for you to do. So मैं ये सवाल करना चाह रहा हूँ 43, which is what volume of oxygen is measured at room temperature and pressure is needed for the complete combustion of 0.1 moles of propanol. So this is the combustion of alcohol. First of all, in alcohol, you cannot use CXHY. CXHY can be used for all hydrocarbons. So what you do is write the formula for propanol first, which is CH3, CH2, CH2OH. That's the first part of writing the structural formula. But for the combustion equation, you should use the structural formula to write the molecular formula. So molecular formula for propanol will be C3H8O plus oxygen will make 3CO2 and 4H2O. And the idea is that you cannot use CXHY. So you got to be able to balance it out by hand. How many carbons are here? 3, and hydrogens are 8, so you need 4H2. And you got to work out the number of oxygen atoms. That's pretty simple. You count the number of oxygen atoms here. Kitne hai isme? 6 plus 4, that's 10 oxygen atoms. But you already have used up 1 in the formula, so you need 9 here. How do you get 9 here? 9 over 2. So 1 mole will react with 4.5 moles. You don't care about anything else. But then the question is about how many moles? 0.1. So 0.1 mole will react with 0.45. That's the ratio now. And you then want to find the volume of 0.45. This seems very simple and basic O-level stuff, right? Because the volume of gas is number of moles into 24 dm cube. This will be less than half, which is about 10.8. So that's your answer right here. And you should be able to do the next question yourself. All right? I want to now turn to number 41. The reason I'm going backwards is because the latest questions are at the end of the worksheet. So I'm just going backwards. Question. Now, the one thing the reason why I want to do this question is because this question is asked multiple times. Because this is a mixture ki combustion of methane and ethane. And what people do is they tend to combine both methane and ethane into one equation and then write the equation. That's not how mixtures work. A mixture implies you have to burn each compound separately. So to solve this question, you should burn methane and ethane separately. And if anybody does try to combine them to react, it might work in this particular question, and only because they have the same mole ratio. But it will never work in any other form. But I would recommend everybody works the equation separately. Now in this case also, the question is asking for the gas is being sparked with oxygen. After cooling, the gases are passed through potassium hydroxide. And we know what potassium hydroxide does. It absorbs carbon dioxide. So the volume of gas absorbed by alkali is carbon dioxide. So what they're asking you to do is find the volume of carbon dioxide produced. That's simply what they want to do. So now in this particular case, you want to find the volume of carbon dioxide. So I don't even care about oxygen. I don't. I just care about carbon dioxide. So CH4 will make how much carbon dioxide? 1. And C2H6 will make 2. So 10, if 1 makes 1, 10 cm cube will make 10 cm cube. And if 1 makes 2, 10 cm cube will make 20 cm cube. Total is 30 cm cube. Hence the answer is Charlie. So you can try question number 40 yourself. Then let's look at number 37. So this question is about carbon monoxide, nitrogen monoxide and sulfur dioxide. So now in this particular case you need to realize that which reaction concerning these compounds occurs in the atmosphere. We know that इन दोनों का relationship क्या है? NO and sulfur dioxide. What does that NO first becomes? NO2. And the NO2 reacts with SO2 to convert it into NO and SO3, which means that SO2 gets oxidized to SO3 while NO2 gets reduced, or NO here gets oxidized to NO2. And so which of the reactions are concerning these guys true here? See, NO is reduced to NO2 and SO2 is oxidized to SO3. SO2 is oxidized to SO3 but by not CO2 but by NO2. So we know the answer is therefore Charlie here. All right? Follow? Then again I'm skipping cracking for now because I want you to see the video before you solve them. Number 35 is, you should be able to do this later, guys. The reason is that this should not be here. This should be actually in later chapters, because only then when you do electrophiles and nucleophiles can you be able to do this. If you guys are considering to do this later, understand that electrophile, CH3 electrophile will mean CH3 with a plus charge. And CH3 nucleophile is CH3 with a minus charge. Meaning this has lost one electron and this has gained one electron. And using that you can solve this question later if you want. I'm just leaving the data here. So for the stuff that you will need to know later, and then you can solve this later. Alright? Just quickly going through some of the questions. Yeah. Okay, yeah, what I'd like to try see if you guys can solve is solve 28 and 30 right now. Alright? And I'll hold off till you solve it. Now, why is it? You see, 1 mole reacts with 3 moles to produce 1 mole and 2 moles. So 10 cm cube will react with 30 cm cube to produce 10 cm cube and 20 cm cube. But you started with 50 cm cube oxygen. So how much of oxygen is left over? Left is 50 minus 30. That's 20 cm cube. What is the volume of products? 10 plus 20, which is 30. So products 30 bane, 20 left over oxygen hai. So what's the total volume of gas after burning? 20 plus 30, which is 50. Once you have that information, then when you pass the gas in aqueous NaOH, NaOH will absorb acidic oxides. Both CO2 and SO2 are acidic. They will be absorbed, meaning these two gases will both be absorbed by NaOH. So when they're absorbed, they're no longer there. So what's left? Only leftover oxygen, which is 20. Therefore, the only option that does satisfy both is Charlie. For those who mentioned B, must have forgotten about the leftover oxygen. It's a common mistake people make. Please always keep in mind leftover oxygen. Then, question number 30. So I'll solve 30 here. But for that, if you can convert this into moles and pani into moles by dividing by the MR, this comes out to 0.8 moles. And pani also comes out to 0.8 moles. Which means that CXHY, which is the formula, generic formula, plus XO plus Y by 4O2, that becomes XCO2 and Y over 2 H2O. The moles are 0.2 moles reacts with 0.8, sorry, gives 0.8 and 0.8, right? Which means ratio is 1:4:4, which means that x is 4 and y over 2 is 4. Y over 2 is 4. So what is y then? 8. So therefore the answer is delta. Not C4H4 because it's 4:4. It's C4H8 because x is 4 but y over 2 is 4. So y must be 8. That's the answer. All right? Okay? All right, we'll leave the class here now.